Hi, good morning, one and all. Myself, Dr. Srinu Varla, Department of Biochemistry. So today we are going to discuss about principle of chromatography. Principle of chromatography. So here, what is the principle of chromatography? So first, before we are going to discuss about chromatography, we have to discuss why we have to do the chromatography. So if the individual components of a mixture have widely dissimilar physical and chemical properties, it is very easy to separate one from another. So generally the compounds we can easily separate by physically. For example, if you take this is a duster, so this is chalk piece. So we can discriminate these two simply by physically. So if you want to chemically, we can separate because this duster, it is generally made up of cellulose. This chalk piece, it is made up of calcium carbonate. So we will add some reagents, we will get the color. So based on that we can identify these two. So these two are we can identify simply by physical and chemical. So now going to some of the individual components of a mixture get more and more similar in physical and chemical properties. So here are some components, physical and chemically same properties. Okay, so it becomes increasingly difficult to separate them from one another. For example, most amino acids resemble one another rather closely in physico-chemical properties. It is impossible to separate a given amino acid from a mixture of several by conventional separation methods. So if it is if the two components have the same physical and chemical properties are there, so those we can't separate clearly. Okay, we can't clearly identify that. So example, if you take amino acids, the amino acids are different only branches, so it has the same physical chemical properties. So those individual those amino acids we can't separate individually. So those type of compounds which are having the physical and chemical properties are the same, those type of compounds we can separate by chromatography. So in the chromatography, the feature common to them all is that two mutually immiscible phases are brought into contact with each other. One of these phases is stationary while the other is mobile. Different components of the sample mixture interact with the two phases differentially on the basis of small differences in their physical chemical properties. The compound which interacts more with the mobile phase and the least with the stationary phase migrates fast. So here mainly the chromatography we are used two phases. One is mobile phase, another one stationary phase. So these two are immiscible. So these two are not mixed. For example, if you take water and oil, so those two are immiscible phases. Like this, here we will take the two immiscible phases. So with the two immiscible phases, our component will be differ in their physical interaction with the physical chemical properties. Okay, so which have a small differences in physical chemical properties. So those compounds interact with differentially with the stationary phase and mobile phase. So if the component more interact with mobile phase, it will move faster, which the compound it will move if it is interact with stationary phase, it will move slow. Okay, so based on that the compound will be separated. So the first detailed Description of chromatography is generally credited to Michael T. Sweat, a Russian botanist, who separated chlorophyll from a mixture of plant pigments in 1906. Because of the nature of the pigments in the sample, each band had a distinctive color. So, thus the name of the process was coined from the Greek words for color, chromo, and to write, graphy. So, chromatography, chromo means color, and graphy to write in Greek. So, the Michael T. Sweat first separated the plant pigments in 1906. So, now we will see the basic of principle of chromatography. So the basic principle of chromatography, partition coefficient, also known as distribution coefficient. So what is the partition coefficient? Here partition means here the compound will be partitioned in between two immiscible phases. So here coming to the definition, in which a given compound distributes or partitions itself between two immiscible phases, the stationary and the mobile phase, the solute upon entering a chromatographic system immediately distributes itself between the stationary and the mobile phase. If at a given time during chromatography the mobile phase flow is stopped, the compound will be in equilibrium between the stationary phase and the mobile phase. At this stage, the concentration of the compound in each of the phases is described by the partition coefficient Kd. So Kd is distribution coefficient or partition coefficient equals to Cs by Cm. Cs means concentration of solute in mobile phase. Cs means concentration of solute in stationary phase. So here the compound itself it will be distribute in between the two immiscible phases like stationary and mobile phase. The solute upon chromatographic system immediately distributes itself between the stationary and mobile phase. So during the chromatography, the mobile phase flow is stopped. The compound will be in equilibrium between the stationary and mobile phase. At this stage, the concentration of the compound in each of the phase is described by the partition coefficient. So this is about partition coefficient principle. So based on that, the compound, okay, which are the compounds have physically, chemically dissimilar. They are not dissimilar here, very low dissimilarities. Okay, physical, chemical, those compounds we can separate by partition chromatography, partition coefficient principle or chromatography. Okay, so this is chamber. So if you take this is solvent and this is the stationary phase like paper. So the solvent is immiscible and the solvent is not immiscible with the it is immiscible with this paper. Okay, so the compound here we are, if it is we are placed here. Okay, so while moving of mobile phase, the solvent also move on the stationary phase. It will be separate the compounds, based on the interaction with the stationary phase and mobile phase. Okay, so after certain time, these compounds are equilibrate in between the mobile phase and stationary phase. Okay, then we start the solvent, so that we can call as solvent solvent flow we can stop that. That is where it is stopped, we can say that it is a solvent front. So now we can calculate RF values. Based on our RF values we can find out the, or we can separate the individual, we can identify the individual components. So this is about the partition coefficient. Thank you.